Okay, we're in section 5. We just completed the lecture on the limit laws. The bottom line, though, is I really can't say enough times, hopefully you're looking at your textbooks and also reading the limit laws. And sometimes they do a lot more work than I would do in doing a limit. And the reason that they're explicitly stating what laws they're using, how they're using them, when they're using them. And it can get really kind of unruly. So when I do the examples, I realize, a lot of stuff I'm writing down over here might be confusing to you. It requires thought. This does require thought. All right. So as I do these problems over here, I'll do them. I'll do problem number 1. I'll do problem number 2, do 3, I'll do 4, do number 5. I'll do number 6. And then, of course, there'll be a chance for you to try stuff on your own. And I get there's not many examples given to you, but the point is, at some stage, you've got to get comfortable doing things on your own. And that's what we're trying to get you to, doing things on your own. Like saying, I want to drive now. We want you to drive. All right. So I'll go through a few examples here, and I'll go to the whiteboard to do it. And it's amazing when you're looking at a textbook, they'll actually write down every single law, and they got them numbered and stuff, as if we're like a legal case or something. But I'm gonna write down what I'm gonna do initially, but over time, you're not gonna see me even write this stuff down. But this is a limit of a quotient. So what I'm gonna do is I'm gonna look at the limit of the top, and I'm gonna look at the limit of the bottom. Well, the limit of top is really simple by limit law, it's just 1. The limit of the bottom by limit law is really easy too. It's just 1. So what's this going to be over here? It's 1. That's done. Let's go to the next one. More difficult because they're roots. All right, let me write this over here. So I'm going to write down, this is going to be the limit as x approaches 8. I'm going to write this a little differently though. 3 cube root of x squared. All right, minus 16 over x. Well, again, in the future, you're not going to see me do what I'm doing now. But I'm going to write this as 2 separate limits. So 3, yeah, I'm using limit laws. Minus 2 limits. Limit as x goes to 8 of the number 16 over limit x goes to 8 of x. Well, I got to be honest with you. I think that the second limit is really easy to do. I'll write that down. So 16, the limit of the bottom by limit law is 8. I use the limit laws over here. Well, what's nice about cube roots are really kind of nice. I don't have to worry about them. It's the even roots I got to worry about. So what would you get over there? It's really just, basically the limit law. There's no problem with this cube root thing over here. So what'd you get? I guess you get 4. So it's 3 times 4. All right. Using limit laws, by the way. Let's see if we can do the arithmetic over there. That would be 12 minus 2, which is 10. All right. Let's do this one over here. A little more complicated. Now look at the limit of the top. X goes to 9, root x. That's an even root, by the way. And the bottom limit, that's a more dangerous thing to be looking at. X goes to 9, x minus 2. Well, I'll be honest, what's nice about the bottom, limit's really simple. It's just simply by limit laws, it's just 7. I got to be really careful about the top, though. And my claim over here is that, well, we're nowhere near the 0 where we have problems. We're at 9, so just root of 9, which is 3. All right. Well, this one over here, I'm going to put this one down. This is going to be the limit. I'm going to the inside now, limit. I'm using limit laws without citing which law I'm using. Well, if I did this one over here, I'm going crazy with it too, 18 limit x goes to 1/3 x squared. I'm using a limit law minus the limit x goes to 1/3 4, and it's all to the 4th power. Whoa. This can be 18 times, well, limit law lets me do that one. That's 1/9, and that's minus 4 to the 4th power. This is crazy. Well, 18 times 1/9 is 2. And 2 minus 4 is minus 2 to the fourth. And that's going to be what? Positive what? Let's see, 2 times 2 is 4, 816. Not so bad. Use some limit laws over there. This one says, can the quotient law be applied? I don't know. Let's try it. So would it be limit x goes to 0, sine x, and limit x goes to 0, x. Well, that's trouble, isn't it? I'll tell you why it's trouble. The limit of the bottom is 0. So I can't use this. And why can't I use it? It's because the limit of the bottom is 0. I can't do it. There's got to be another technique here. All right. Number 6. And I'm going to claim out, I want to do number 6, but I'm going to do it using technology. What does that mean? Well, I got to go to my computer, and let me do that now. And I'm going to go to a new share. And I want to see if I can do this limit. Now, granted, we're not expecting your expert use of technology now. As you move through your careers, though, you want to become more and more comfortable using technology. So I'm going to open up my terminal. I have Sage running already. And I know they said use a graph and or tables of values. The first thing I do is I just want to do limit. No, I'm not expecting to know the command. Sine x. You know, I'm going to do, let me just start more formally. Reset. X is a variable. Those students have taken me in math, you know, like 100, 119, 120, and now you're in 121. For those students, they've seen me do this, I'm going to say, you know, 100 times at least. Anyway, what I'm going to do now, I'm going to say a function f of x. There's going to be a sign now, sine of x, divide by x. That was pretty simple. And now I want to do a table of values. So what I'm going to do is I'm going to go, let's see, I want to get close to 0, but through right values. So I'm going to say, what's a good number to the right of 0? I'd say 0.1. And you get that number over there. Now I want to get closer, and you could do this all day long. I'm going to say 0.01. I hope you realize I'm still to the right of 0, but I'm getting closer. What do I get? Well, it's even getting closer and closer to another number. I don't know what that number is yet. I got 0.9983, 4166, 46, 8282. The next number was 0.99983. You can read that too. Let's go closer. So what's closer? I'll say 0, 1. I'm getting more 9s. I got suspicions now. Put another 0 in. I bet I can get more 9s. I'm going to put another 0 in. I bet I can get more 9s. I can put another 0 in. And by the way, someone says, who's doing the computation? Not me. It's no, you know, I can do that pretty quickly, right? Let's see what happens. I'm going to keep going till see what it hits. I might be surprised that it goes haywire on me. Look at that, 1. That's incredible. Let's keep going. Let's go over left now. So what's a good left number? F of minus 0.1. That's to the left of 0, right? Oh, let's put another 0 in. Let's see what happens. I think you don't understand what we're doing over here. Fairly simple. I'll just keep playing around with it, right? Nice thing about software, it's, you know, the machine's not going to overheat doing this. Certainly, if I had to do this by hand, I'd be overheating now. Let's do another one over here. Wow, look at that. So what's my conclusion? My tables seem to be leading towards that F is approaching the number 1. Now, by the way, from below it, but it does appear to be approaching it. Now what I want to do is I want to plot it. P-L-O-T. What am I going to plot? F of X. Because they did say I could do that, right? So let's see what that gives me. And I'm getting this over here. I don't really like the picture too much. So I do see it goes towards 1, by the way, but I want to get a better picture. All right, so I'm going to do that graph again. Give me 1 second. I'm going to say X min. I don't know. I'm going to say maybe something to do with pi. I'm going to say -6. That's about minus 2 pi. And x max about, I don't know, about 6 maybe. I'm seeing a better picture. And by the way, you can play this game all day long too. All right. What do I mean by that? Let's say I wanted to go out even further than that. Let's say I want to go to minus 12, for example. And there's really no pain in doing this, that you're getting an idea that it can get a nice looking graph. Again, I want to point out what I'm looking at. I'm looking at when I get close to 0. Let me point out this, what I mean by that. You see over here, this is where we're getting close to 0. What does the function look like it's hitting? It's looking at number 1. By the way, it's undefined there. There's actually a hole there. You just don't see the hole. It's so small. All right. It's a very tiny pinprick, so to speak. By the way, it looks like it's approaching 1. By the way, I'm going to do another thing. And again, I'm not expecting that you know what I'm doing at this point, other than the fact that you know I'm using a computer to get my questions answered. Let me just clear the screen. By the way, clearing the screen doesn't clear what I just defined. I defined f of x. And I want to do the limit of f of x at x equals 0. I want to see what it says. It says it's 1. All right. So someone can say, why do I need to learn if a machine can do these problems? The whole point of this is you're learning a skill set. So at some point in your careers, that skill set is going to become so strong that you're going to be presented with problems that require a computer. This problem does not require a computer. This problem is simple. So this question becomes is, well, if it's so simple, why you show me how to use a computer? We're hoping you get to the stage where your skill set becomes so good that a computer is going to be demanded from you. Learn the computer now, right? Although the problems we give you do not require a computer, you should be able to use a computer. Let me just go back over my problem set. And I'm going to look at these things over here. I don't want to do each one of them, but let me do one of them. Let me do this one over here. I'm going to define a new function, f of x, to be equal to the square root sqrt of x divided by x minus 2. Okay. I'm going to do the limit. And let's take a look at that. I'm going to do the limit of f of x. And I'm going to say x equals 9. I think if you remember, I'm going to look back over my notes, by the way. And when I mean look back on those notes that I've written for you, I said 3/7. This says 3/7. Remember I said there's going to be a problem at 0? All right, so what I'm going to do is I'm going to plot and tell you why there's a problem at 0. By the way, you notice it even said something about failed warning over here. So someone says, what's the problem? Well, when I look at this thing, do you notice that this thing over here, there seems to be something going on over here? I'm going to say it's only approachable from the right side. So I want to briefly do that for you. And I'm going to say it's really not an issue for me to do the problem. Machines can horribly confuse with simple questions, by the way. And you need to be aware of that. That a lot of times when using software, you need to become an expert in the use of software so you get to do what you want. So I'm going to do that limit again. And I'm going to say x equals 0. And by the way, the answer should be a DNE. It doesn't exist. I don't know what the computer's going to do though. Let me do this. And all of a sudden it says error. You see that? You may understand it. You must say, oh, I typed in something wrong over there. Let me just do this. And I'm going to say direction equals the right side. Let's see if it can do it. No, it gives me another error, by the way. And someone says, why is that? Well, I guess there's a problem over there. All right. But from the right side of 0, it actually equals 0. It can't do the limit. So let me point this out. This can be troublesome. I do like Sage, by the way, but I want to point out for a lot of students, it's an overwhelmingly complex application. So I want to briefly talk about Wolfram Alpha now. And I'm sure you're aware of this. I think every student at Essex County College has seen this application before. All right. So let me type this in. I'm going to type in limit square root sqrt x divide by x minus 2. You know, I want to go back over here for 1 second. I just want to type something in here. Yeah, I typed in the right function. Sorry about that. Go to Wolfram Alpha. X over X minus 2. X equals 9. By the way, I don't understand it. The one thing I like about Wolfram Alpha, though, even if it misunderstands me, and it misunderstood me. So I'm going to say the limit square root of X over X minus 2 as X goes, I don't have to understand this either, goes towards 9. And again, I don't understand that language either. Someone's like when you're talking to someone, they understand you, got to keep rephrasing it until they do understand you. Don't keep saying the same thing over and over again, though. And I notice over here, it's still having a tough time, isn't it? Oh, I'm going to put something else in here. Finally understood me. See that? How many times I give my question at Wolfram Alpha? A few times. I'm going to do this one, see if we can do it. By the way, the answer is 3/7 as we expected. All we're going over is tools. This should be does not exist. The limit doesn't exist there. Let's see what Wolfram Alpha says. Wolfram Alpha actually said it's 0, and that's not true, right? Now they're talking a little more advanced than us about real and imaginary. We are no longer, I'm sorry, I shouldn't say no longer. We are not dealing with complex analysis at this level of the game. But I'm going to put this in over here. X goes to 0, and then I'm going to put down left. I'm going to see if it understands that. Yeah, it does. And you know what? It's still doing the complex part. And I'm sorry about that. And that's something I have to be aware of, that on an exam, we're only dealing with real numbers, and this limit doesn't exist. Our limit laws wouldn't allow us to do that because it's a complex number. Although it's 0, it's still not a valid answer, right, at this level of the game. Sorry about that confusion. Again, what I'm trying to say over here is that, yeah, get your feet wet in the technology business. But every question we give you over here, I mean, every single one we give you for the most part is going to be done by hand. There are some things where we tell you to use a computer because we have to compute things. Like, for example, number 6, I had to compute tables there. No way I could do that by hand, by the way. But if I was doing it by hand, it would be frustrating and take me forever. All the questions over here, limit laws, limit laws. Wow, limit law, limit law. These are things you need to know. This one over here, limit law. There's no problem. I'll tell you why. 25 is nowhere near 0, and no problem whatsoever. All right. This one over here, a little cryptic, but we can do that using limit laws. We can do it by limit laws. This one we can use by limit laws. This one we can't do quotient law on that. But I'll be honest with you, there's a good chance we'd be able to do that by using a computer. All right. But we couldn't use the quotient on that. And the reason for that is the bottom is division by 0. All right. So this one over here, let's see. This one's a little difficult. I want to be honest with you. For a lot of students, what's difficult for them is not this problem over here. It's the tangent. And unfortunately, if you thought about it, 8 times that number over there with pi over 2. And I hope you realize that the tangent function at pi over 2 is asymptotic, and it's going in 2 different directions. But again, I would recommend trying to use technology to answer that question as well. All right. And then 10 gives you more, and try to work through that. I know it's troublesome for some students. Some students say, so do I really need to understand and work? That's what we're really trying to teach here. That is the working towards this goal of understanding something, including if you're never going to use it. I'm hoping, though, that if you're in a STEM-related career, at some point in your careers, you'll be using things like software and your prior knowledge that you've learned in school. And that's what we're hoping for. Thank you for your attention, though.